Hello, this is Yannis from an-515. Today we will go through an Acer Nitro 5 an-515 gaming notebook repair that came to our lab dead. Let's go and see what we will deal with. Here's the board. We have it on our desk. We have removed it from the chassis in order to check it with our multimeter and check whatever they told us to check. They told us that another guy removed the PCH, have changed the charging IC, and after this work, he determined that GPU is faulty and this machine is beyond repair. Now we will have an inspection on the board and we will have our own decisions about it. The PCH is soldered by factory. You can see the silicon at the edges. So I don't think that anyone ever have changed this PCH. I don't think that is true. The charging chip seems okay, no flags, no any sign of soldering or desoldering. I don't think that the charging chip is ever desoldered or soldered as new. And the remaining GPU fault, I think, will go in the bucket because we have already done our check and saw that we have a short on this coil. This is a 5-volt coil. We have removed beside the capacitors in order to check if these capacitors are broken. We have a short, as you can see, on the jumper. You can see the ohms are very low. And also we have a short on the coil. We had a short on the coil in this part of the board. It was shorted by the regulator that produces the 5-volt. We have removed the regulator and we have cleared the short of the 5 volts. And the other thing that we have noticed is 3-volt LDO short. You can see 5.5 volts, ohms, I'm sorry. And we have already soldered our DC connector in order to inject some voltage. We can see that the 5-volt coil is connected with the regulator and the jumper, and the LDO now is connected with the not directly with the PCH, it's directly with the Super IO. Thank God, not the PCH again. So the Super IO is the primary suspect for this short. So we'll inject voltage in order to see something hot on the board. Hopefully it will be a Super IO. And now we will inject 2.5 volt on the LDO, and we are having 330 milliamps consumption. And we will try to locate. This is it. Super IO is burning. So the Super IO is dead. And these are good news because could be PCH. So Super IO is dead. And after that, we must check for the 5-volt short. We will solder the wire now on the 5-volt coil jumper. That way. We will inject 2.5 volts. It's okay. I will plug the charger there. And we are having not almost, an amp consumption. And our thermal camera showing that the CPU phase controller is guilty for this short. And we have to remove it. And replace it, of course. We will check now with the isopropylic. It is burning, you can see it. So we must remove it and see what will happen with the short. So the conclusion is that we must replace the 5-volt regulator, the Super IO, and the CPU phase controller in order to make things better for this board. We are removing now the Super IO with the hot air and our tweezers. It is moving. We will lift it with our tweezer and we are okay. We must check now if the LDO short is gone. But first we must clean the pads in order to remove any bridges from the solder that was lifted before. We will use fresh one to start. And after we will clean with our wick and our soldering pen. We will clean it for two reasons. The second one is the replacement of the Super IO. Should be flat like that and clean. So let's go and see what happened with the LDO short. The LDO is clean from shorts, so we're good. Now the 5-volt rail is short because we're having this guy here, which is burned, and we must remove it. It is a common issue, the 5-volt rail shorted by a GPU regulator or a CPU regulator. Now we will remove the controller. We will clean the pads to remove bridges and prepare the pads to engage and solder the new phase controller. We will add some flux, and with a wick and the soldering iron we will remove any bridges and the old solder. That way. Okay. Now let's go and see the 5-volt rail short. It is still shorted. 4 ohms. Wow. So let's go and see what else is shorted. We will inject the same voltage on the same rail, and our thermal camera will show what is shorting, what else is shorting. And now we are having probably it is USB related. Yes, I think it is USB related. It is very close to the USB. It needs 5 volts, so it is obvious that we are dealing with a USB volt 5-volt rail short. Let's see with this isopropylic, and this is burning hot. We will remove it and see what will happen, and we will deal with this later. It's just a USB rail, can be plugged from any 5-volt S0 state voltage. So let's go and remove it. Okay, it's moving. It is off. Now there is no short pads. We must see the 5-volt rail again. Hopefully it is clear. And yes, it is clear. Yes, of course. We have a clean 5-volt rail. We had 2 components that was short. So let's go and try to replace the missing components. We will go and replace the phase controller first, adding flux, wiping a little bit again. I will add the new solder on the pads, and after that I will solder the new phase controller. We will prepare it. We will add some flux and solder on its pads in order to make our job easier for soldering. We're cleaning. Press flux first. And after that, soldering with the right orientation. Be aware for the white dot. You shouldn't do anything else because we will have certain problems. The chip is aligned. We'll press it down. And now we will check for proper connections, and we will add some flags and renew the solder with the fresh one around the chip in order to for the joint to be better. We will do it, and the chip will be like that. Now we will go to the Super IO. Quickly. We will add some flags and do the soldering job. First, we must align. We're pressing with our fingers in order not to misalign the chip in order to have it flat and ready for our soldering iron. We're anchor some pads with some corner pins. We don't mind for bridging. We will deal with this afterwards. And after the soldering is done, we are checking with our tweezer for any pin that is not connected properly. And after that, we will go to the 3 volts LDO in order to check if it's still clean from shorts. It is, as you can see. We're having a clean line, and now the 5-volt rail must be soldered back. The coil, the regulator, the caps on the right hand side of the coil. The jumper must be recovered. The caps must be placed on its everything on its position, and there is a missing cap there. We will deal with it later. Maybe from the other tech that has worked on this board. I don't know. And now we must solder the 5-volt regulator. Okay. We must align it. Add some flux. Hot air gun. And I think we're okay. Check for short. There's no short. And now we have already assembled the board, heatsink, the CPU fan. We will try to inject our desk power supply and check the amps consumption. I'm checking the USB in order to see if we have a caps lock activation, when we will, of course, trigger the notebook, the motherboard. We're trying to trigger it with our tweezers. It's getting some amps and then off. It's getting some amps. I think it is RAM training. The CPU is getting hot. We're trying to see if we're having a caps lock signal. It's on again. We're pressing the heatsink because we are too lazy to screw some screws on it. It is off again. I think it's RAM training. We are in a good way. I have put the notebook back on its chassis. Because caps lock didn't show up. Now we will try to trigger the notebook by the keyboard, but the keyboard is broken, so we will use our tweezer again. Same thing, the same RAM training. I'm holding the board not to fall from the chassis. We have a good consumption. Come on, it's off again. It's on. We must have display. The last thing we must have in order to see that it's working. It's off again. Wow, this is it. Acer. We have a display, we have a splash screen, of course we have no drive. So we think that we are okay. The problem is solved, the fault is no more. That was the repairs you saw. If you like this video, consider like, subscribe and share. Thanks for watching. See you in another repair.